Hello, and welcome to today's lesson where we're going to look at the volume of a sphere. Okay, as we're working through the volume of the sphere and volume of a hemisphere, we'll actually show the connection between the volume of a sphere and the volume of a cone. So now, when we're looking at this shape, we have Mona, who has a plaster cube, 12 centimeters on each side. Her assignment is to carve the largest possible sphere from the cube. What is the volume of that largest sphere? So now, when we look at the volume formula for the sphere, 4/3 pi r cubed is our volume formula. So now, when we look at this one, we've got a diameter side to side of 12 centimeters. So we need to break that into a radius of 6. So now, for finishing our volume, we've got 4/3 pi 6 cubed. Okay, so we want to cube 6, and my SmartView calculator isn't working today, so I've got to do a little handheld work here. So we've got 6 cubed is 216. We're going to multiply that by 4 and divide that by 3 to see if it works out perfectly. Okay, because we do want our answers in perfect form. So 6 cubed is 216 times 4 is 864. Okay, so we can have 864 thirds. And remember, the pi is just something that we tack on the end of that value when we're looking at our answers. And since this does divide out perfectly, we want to list it in perfect form. So we have 288 pi as our final answer, and then we want to put our units on it, centimeters cubed. Remember, when you're entering in Schoology, if you want the full answer, it'd be 288 pi. A lot of times we're leaving the pi tag there for you, so all you have to do is type in the initial value of 288. Okay, now let's work this backwards. A sphere has a volume of 500 pi over 3 inches cubed. Now we need to find the radius. So once again, this is going to be a solving problem using our volume formula, 4/3 pi times radius cubed. And we're going to set that equal to 500 pi over 3. Okay, now, one thing that we want to do is we want to try to clear off equal values on either side as we get started. So if we notice the denominator here, both of the denominators have a 3. So if I multiply both sides, so I'm going to multiply this side by 3, and I'm going to multiply this side by 3, it clears off those values. So now I've got 4 pi radius cubed equals 500 pi. Now my next step is I notice that both of these values have a pi as a part of them. So I'm going to divide out the pi from both sides. And what I'm doing is I'm just clearing off values to make this its simplest form possible. So now I have 4r cubed equals 500. Okay, now when we solve, we have to get rid of the 4 first before we can get rid of the 500. So I'm going to divide both sides by 4, and I now have r cubed equals 500 divided by 4, or 125. Okay, now, finishing this off, how do we get rid of the cubed value? And what we're going to have to do here is use what we call a reciprocal exponent. So to get rid of a cubed value, we would want to do the cubed root, but we're going to raise it to the power of 1/3. So we're going to raise both sides to the power of 1/3. Okay, that takes care of our exponent on this side. And then when we type it in, you have to be careful when you type this in. Okay, parenthesis 125, close the parenthesis, and then do the power, and then put your 1/3 in parentheses as well to make sure that your calculator is going to do it correctly. Some calculators would do it correctly without these last parentheses, but you always want to be safe and put them in. And then we finish up and we get a radius of 5 inches. But really the new thing here, we've square rooted before to get an answer, but the thing that's really new here is having to do this 1/3 exponent to get rid of the cubed value when we're solving here. So that's one thing that you want to pay close attention to and be careful with. Okay, now, when we look at a hemisphere is half a sphere. So if we look at our volume formula, the volume equals 4/3 pi r cubed, and all we want to do is multiply this by 1/2. Okay, now when we do that, we can do the 4 divided by 2, and we get 2/3, which is half of 4/3 pi r cubed. Okay, so then any radius we have, we would plug it in for r, cube it, multiply by the 2/3 to see if we get an exact value. If we don't get an exact value, make sure that you turn it back into a fractional value. Okay, so now, here's a pretty tough example here, just showing how we can use hemispheres. We want to find the volume of the plastic to the nearest cubic inch needed for this hollow toy component. So what we have to do is we have to take our outer volume, which would be a solid component, and subtract the inner volume from it. And then that gives us that bowl shape that we're looking at here on the left. Okay, now, always be careful. We're given diameters here. Okay, so we have volume of the outer sphere, 4/3 pi 3 cubed. And we've got the volume of the inner sphere, 4/3 pi 2 cubed. And this is something that we just want to plug into the calculator here since they say to the nearest cubic inch. So we're going to round both of these values. So I have 3 cubed, which is 27, times 4 divided by 3, which gives us 36. And then we're going to multiply by pi, and we get 113 cubic inches rounded to the nearest whole inch. Okay, now for our second one, we've got 2 cubed, which is 8. So 8 times 4 divided by 3. Okay, 10.6 repeating. Okay, we're going to multiply that times pi. And we get 33.5, so we have to round that up to 34 cubic inches, okay, because they wanted us to work with our values to the nearest cubic inch. So what we have is this volume would be the complete solid, this volume is the inner piece, and we subtract those out to see what's left. 113 minus 34. And we would need, so when we subtract, we finish, we've got 79 cubic inches of plastic. Okay, so we've got a very big piece here as we're going through and solving. Now, does anybody notice the one mistake here? I was hoping maybe you were thinking about it. Okay, what is the one piece we didn't do for this problem? These are hemispheres. We need to divide by 2. Okay, so when we're dividing by 2, okay, we've got 113 divided by 2. Okay, 56.5. Okay, so we'll round that up to 57. Okay, we had our 35 or 34 divided by 2, which is 17. Okay, so always be careful. Are you dealing with the volume or are you dealing with the hemisphere? I use the volume formula, so I have to cut it in half. If you wanted to use the hemisphere formula, you could definitely do that as well. So we have 57 minus 17. So we have 40 cubic inches of plastic in this shape. Okay, now we can start putting together different shapes when we're looking at volumes. So in this situation, we have a hemisphere on top, a hemisphere on bottom, and we've got a cylinder through the middle. So if I want to find the volume of this shape, what I can do is I have two hemispheres, so I can use one sphere formula, because I can bring those two hemispheres together. Okay, plug in the radius of that sphere to get that value. But now I also have, so this was the volume of my sphere, now I have to do the volume of the cylinder. Okay, volume of the cylinder, if you remember the formula, area of the base times the height. The base shape is a circle, so it's pi radius squared times the height. Okay, we know our radius is 3, so we have pi times 3 squared times 6. Okay, and what we want to do is finish this workout, and we would combine the two volumes by adding. We wouldn't multiply the two volumes together. Okay, so our first volume, we've got 3 squared, which is 27. 27 divided by 3, which is 9. 9 times 4 is 36 pi. So that would be our two hemispheres put together for their volume. Now, when we're looking at our cylinder in the middle, 3 squared is 9. 9 times 6 is 54. So we would have to add that 54 pi on to finish up the two pieces. So we've got the volume of the sphere, the volume of the cylinder, and we would put those two together to get a total volume of 90 pi. Remember, if you're dealing with just an image, we want to work in exact values as much as possible for those problems listed there. Okay, now finishing up, we've got a couple extra examples here to wrap up. Here we've got a situation of an ice cream cone type volume. So once again, we have to break it into our pieces. So on top, we have a hemisphere. So instead of 4/3 pi r cubed, we're going to use the 2/3 pi r cubed. And then we've got the volume of a cone. Okay, and from before we saw the volume formula for a cone, 1/3 area of the base, pi r squared, times the height of the object. Okay, so we're going to be putting these two pieces together to get our solution. Okay, so we've got the volume of our hemisphere and then the volume of the cone. Okay, so we want to plug in what we know. We've got 2/3 times 3 cubed pi. Okay, remember, we want to just leave the pi there. Gives us an exact answer that we can work with. And then for our second piece, we've got 1/3 times radius squared, 3 squared, times our height of 10, and then pi. Okay, so you always want to be careful when you're going through and simplifying these formulas and finding your answers. So we have 3 cubed, which is 27. 27 times 2 which is 54. 54 divided by 3. Okay, so our hemisphere volume is 18 pi. And then we have our cone volume. 3 squared is 9. 9 divided by 3 is 3. 3 times 10 is 30 pi. Okay, so we have to put these two together. 18 pi plus 30 pi gives us 48 pi centimeters cubed. Okay, and then this gets us into our homework for the lesson. So that concludes our lesson for today, working with the volume of a sphere and volume of a hemisphere. Thanks and have a good day.